This episode of the EV Resource Podcast is brought to you by Oasis Charging, offering commercial and residential customers comprehensive EV charging solutions with a consultative approach. For more information and to schedule a free consultation, go to oasischarging.com. Coming up this week, well, hello, friends, and welcome to episode 202 of the EV Resource Podcast. I'm Zack Hurst, and each week I bring you the latest EV news, information, and interviews with industry experts. And this week I'm joined by Dr. Ian Campbell, the CEO of Breathe Battery Technologies. We're going to be talking about software and how software can improve charging. Ian, it's a pleasure to have you join me.
Likewise, Zack. Pleasure to be here with you and the podcast and all of the listeners. Thank you.
I know we're going to get into a lot of things and explore an area that really has not been talked about a whole lot. I see software being somewhat behind the scenes where, of course, hardware or even battery chemistries get the spotlight typically. Before we get into everything, though, I like to give my guests the opportunity to speak to their background, their origin story, if you will, so that we have a greater understanding of who we're listening to.
Yeah, sure thing. I can absolutely elaborate. So I'm a mechanical engineer by training, but even prior to going through that sort of educational pathway that I found very enjoyable, very insightful, I had started to spend quite a bit of time in a hobby context playing with and racing really at a fairly competitive level then these radio controlled cars that had small nitromethane fueled engines in them, but carried quite a bit of electronics as part of servo motors and radio receivers and so on. And they were all powered by these very colorful cells that were shrink wrapped into equally colorful and interesting battery configurations and layouts. A combination of pouch cells and cylindrical cells of all shapes and sizes that were sourced from companies like GP Batteries and Sanyo and various firms around the world. And they would occasionally cause me to have a car failure during a competitive event, and that was incredibly frustrating for me during my hobby experiences, not getting the outcome that I wanted. And I was fascinated by the battery itself, by the fact that it became warm, so warm during the charging process that I had a blue TLP charger that possessed this fuzzy logic mechanism for charging the battery that I didn't understand either, but was fascinated by the language and the description of it. And really wanted at the time to, I think, understand why the battery wasn't performing better, why my race outcome had failed because of a piece of electronics and so on. But I think at that point in my young teens, didn't understand it, certainly to the extent I've been able to in the last number of years. But got that first exposure to batteries in a context that was important to me during those years, and subsequently continuing the motorsport on as a hobby into even into full-size single-seaters through Formula V and Formula Ford over the last maybe 7-8 years. The battery tech has perhaps become even a little bit more old style. The transition to lead acids, part of the electronics in those, but I think the battery hasn't gone away in the personal life either. And when I look, of course, then outside, of course, the motorsport world and let's say the real world, the bigger world, you, me sitting here, our friends and family, we have so many batteries on us at any one point, in the smartwatch, the phones, the laptop, and now the vehicles in the driveway as well. So I think I went through then that experience in the years, especially sort of 2013, 2014, post a master's education here in the UK then. I was looking at what was happening especially with Tesla and with the electrification of transport, and felt very strongly at that time that the transport sector, starting with passenger electric cars, needed to electrify, particularly for local emissions reasons, with the air pollution that we suffer from so badly here in London and so many cities, and also with generally, I'd say, also with the effect it has on the wider climate and what we experience with climate change around the world. And I felt then that, I think from a personal perspective, that I had an opportunity to satisfy that interest and that desire that never went away to understand what was happening inside the batteries, with solving a problem that was, I think, very important, I felt, for me and for everybody else in terms of our health and the happiness that we have and the environment around us with transport electrification. So I made the move from where I was living in Germany at the time, around that 2014 period, back to London, where I'd spent a little bit of time prior to that, and started a PhD then in Imperial College in battery engineering, and was fortunate to seek out what turned out to be an excellent choice of academic supervisor with Professor Greg Offer there, who makes, I'd say, maybe a habit slash career a legacy of helping engineers, I'd say, supplement and augment their engineering background with chemistry and electrochemistry knowledge. And then, as an output of the PhD programs, producing candidates like the many of the talented individuals around me that came out of Imperial at that time and still today, that then have that combination of maybe engineering skills that can apply chemistry and electrochemistry in a way that is able to solve some really pertinent problems. And I think it was essentially then through those years of that electrochemistry modeling, through simulation of physics-based battery models at Imperial in the PhD, and then a couple of years of developing experimental methods for state of health diagnostics on lithium-ion batteries was the context and the application. I got the understanding certainly that I was looking to get, and I've still been trying to develop that, of course, further since. But at the same time, got quite a lot of insight through consulting work into what was happening and what and wasn't, maybe even more importantly, happening in industry. And I think through that, then insight together with that supervisor, with Professor Greg Offer, who's today our chief scientist at Breathe, the company that we co-founded, and a brilliant Chinese battery engineer, Yan, or Dr. Yan Zhao, who's our chief technical officer at Breathe. We three then decided to co-found a company, a limited entity here in the UK, to act really as a conduit for a lot of resource investments of time, of energy, of, let's say, thought cycles and brain cycles, and then investment of all sources, both from equity financing from some great investors around the world, as well as our revenue and some grant financing that we're thankful for as well, and direct that towards changing the state of the art of these battery systems to really try and push them on. And that set in motion then something that started about 5.5 years ago when we spun that company out of Imperial.
So, Breathe Battery Technologies, you said it roughly 5.5 years in the making so far. You've partnered with a major automotive brand to help improve the user experience specifically. So, if you can actually speak to what I'm talking about, I'll let you share and how that came to be and exactly what the goal behind that partnership is.
Yeah, absolutely. So, I mean, in Q1 of this year, the first quarter of 2024, we announced a major sourcing agreement with Volvo Cars in Sweden, where we will supply one of our two flagship products called Breathe Charge to Volvo for their next generation electric car platforms. And that will provide them functionality called adaptive charging, which will facilitate then a substantially improved charging experience for the next generation of Volvo vehicle owners. And I think that's something that Volvo are incredibly excited about, and at Breathe we're both incredibly excited and proud about as well. So I think the rationale, let's say, behind that and what it means to your point is really maybe a little bit requires the backstory or the explanation of the status quo in the industry today, and that's that charging experiences, regardless of what, let's say, size of the application is, whether that be, let's say, the smartwatch or the in-ear earbuds, all the way through to the car on the road, which of course is becoming electrified, and then the maybe energy stationary storage system that you might have balancing the grid or so on. The charging of all of these systems is relatively basic, and it's all typically reliant on a number somewhere that's programmed into the system that says charge me at this number of kilowatts. If that's the car, it could be 150 kilowatts, or charge me at a certain number of amps or watts if that's the smartphone or the watch, and so on. And typically what that results in is a very frustrating scenario that I think is only maybe becoming more clear, I'd say, to both OEMs, the manufacturers of these systems, as well as the general public. And that's that strategy leads to an awfully large underutilization of the capability of that battery system. It could charge an awful lot faster. It could charge an awful lot more consistently in many different scenarios. And you could have an overall significantly enhanced charging experience. And you can have all of that without accepting any kind of additional trade-off, like the longevity of the battery system. And that's really music to the ears of both end users like you and I, as well as the OEMs that are then building these kind of systems and integrating the battery system. And that is then the outcome that we are able to provide with adaptive charging. So we can absolutely dig into a little bit about essentially how that's made possible and what the sort of legacy of actions that this industry has or hasn't taken that mean that there's so much overhead and room there for improvement today. But fundamentally, what an organization like Volvo looks to an organization like Breathe here for is the ability to adopt then a piece of software that's incredibly lightweight that gives them on a very short lead time, so almost overnight, let's say, a very cost-effective way of substantially enhancing that charging experience. And with Volvo, I mean, one of the let's say headline metrics is that under some circumstances, that's as much as a 30% charge time reduction. And I think what we'll see play out both with Volvo and the rest of our customer base in the next years, and as the wider market adopts adaptive charging, we'll see that number become a much more holistic, I think, explanation of how consistent charging experience can be and is measured, whether it's cold, warm, or regardless of where your battery is starting from or not starting from.
To be able to charge and knock off almost a third of the total time, that's really significant. And I've had the pleasure of spending some time with some Volvo vehicles, and I would assume, and you probably know a lot more about this than I do, that Polestar is also utilizing a similar system. And the charging speed had been at that time something that I was a little bit more critical of. So it's exciting, especially when you mentioned that it's not a massive the word you used was light software, where when I think about what would need to be done as an outsider, I'm envisioning millions of lines of code that would need to be written in order to account for almost every variable. So if it's not that, then I mean, kudos, because clearly, from an engineering perspective, you all certainly have come up with a solution that is easy to apply. Let's talk more about what adaptive charging means. I could make an assumption, and I might be right or wrong, but I'd rather just have you kind of give an explanation of what that is and then contrast that with the systems that we're all kind of familiar with.
Yeah, absolutely. I think it's really helpful to take some examples, I think, to try and make it really tangible for us here and also for the listeners as well today. And I think on the most simplistic end, we could take an application that's maybe, let's say that maybe the simplest possible application that you have a battery installed in today, a rechargeable battery, and that might be something like a controller for a games console, or a kind of maybe rechargeable TV remote, or let's say something rather basic. And that will typically have one number that is hard coded into it. I mean, like in sort of programming lingo, it's the magic number, right? And it's just like a random number that is there, and that will dictate the number of amps or number of watts that thing gets charged at. And that what that means is then that practically irrespective of the state of that battery, that it always having that charge current pumped into it. And I think then maybe we come back to this in a second, but the degree to which the assumption that the state is constant is true is very low. It's that state of the battery is consistently changing on very, very many time scales, like a millisecond by millisecond basis, as well as sort of day by day and month by month and year by year. And that's a very important factor. And then why adaptive charging as a say methodology is so potent in terms of the performance increases it can yield. Then if we take a, let's say, slightly more complicated application or slightly more complex one, where you might have a relatively higher battery pack value and or a relatively more, say, noticeable outcome if it is or isn't working well. And we look at, let's say, the car type system, where you might have something like $8,000 to $10,000 today of battery pack, roughly a third of the value of the overall application tied up in the battery. And here you have something that is today relatively advanced in terms of in the say narrow scope of the status quo and what this industry has been developing for the last decades in terms of charging strategy that's programmed into these units. And typically that won't look anything like one number. Instead, there's some incredibly talented engineers inside these organizations, car manufacturers, cell manufacturers around the world. And they are, through a number of different routes, going about building tables that can be quite large and quite complex tables of these numbers that we can, of course, also visualize as three-dimensional maps of then how the charging current or the input power into the system should vary across a number of different states that are varying over time, like the state of charge of the battery. I think we're also familiar with that from the kind of percentage state of charge indicator on our phone and so on. But also how that charging input can vary then as a function of the battery current temperature as well, and its environmental temperature, or as a function of what starting condition that battery is in. Is it young? Is it old? Is it mature? Is it worn out? And so on.
The variables that would need to be accounted for to maximize the safest charging speed while also maintaining, as you had mentioned, the longevity of the battery so that we don't have a battery that only lasts 5 years. Naturally, temperature is going to play a massive role, especially in EV charging, where every single cell, certainly you're not going to have temperature sensors, but I would imagine throughout a pack, you're going to be able to keep track of what is going on and adjust the current running through the batteries. I mean, battery management systems in general range from something very simple, like I've got this for just a little pack I'm playing with, to what you're working with needing to account for so many things because it's worth, in some cases, $8,000-$10,000. That is not something that you want to fail from a financial perspective, but certainly from a safety perspective as well. I mean, usually when battery packs have failed during charging, it's related to heat and something that probably could have been prevented from a software aspect.
Exactly, that is the case. And I think when we think about optimally extracting the performance capability and let's say the end user experience, which is ultimately at our organization at Breathe, what we deliver then to customers, when we think about optimizing that to extract it optimally and fully, we are considering the same scenarios, the same conditions, the same kind of metrics and axes on these kind of tables and environments as we would consider for safety, and as we do consider for safety along with our customers. And I think it's in respect of what we've been discussing so far with Volvo becoming one of our flagship automotive customers in the public sphere today. I think it's particularly, of course, rewarding for us to see an organization with such a high safety focus adopting then adaptive charging as one of the flagship technologies for their upcoming electric car platforms. And I think in respect of that, I mean, fundamentally with the way these then status quo charging strategies are developed, where you then have either on the one end quite a simplistic number or on the maybe more advanced end, quite a complicated table that varies the charging so as to try to optimally extract the performance and protect the battery. I think this comes to then very quickly the limitations of this approach, where always then, regardless of the complexity, where on that spectrum you are, let's say as an end user using it or as a company developing it, what you're doing is you're pre-compiling some numbers and you are saying that, okay, I'm picking a particular snapshot of this battery's state. Maybe that's a new battery and it is at a particular temperature. And I am designing my entire potentially rather complex charging strategy around that single state. And then what suddenly happens is that battery gets manufactured. Every day that battery is on the shelf and in the vehicle or in the application after that day, it's changing as it's aging. And we're moving on the age axis away from that optimal state that our engineers have designed this charging strategy for. And then you're using yours differently to how I'm using my battery. We take them through completely different aging pathways. And at the same time, we have them in different temperature environments and they're starting maybe charging at different states. And fundamentally what happens is that the end user realizes maybe intrinsically by what they're feeling and experiencing very, very fast that the traditional status quo design of charging strategies for a single operating point of these batteries leaves then a huge amount of performance on the table because nothing is optimized for all of the real world use cases. And I think to the question and to the prompt of where does adaptive charging come into all of this, I think fundamentally what we've been developing here at Breathe in the last half a decade now is the subject matter of many of the initial patents that we published and filed. And I think what this industry will rather quickly move towards is a state then where adaptive charging becomes the new standard. because it is both able to optimally extract the performance in all of these different scenarios, adapting really dynamically to the aging and the temperature and everything else, and at the same time providing a level of safety and protection because of that adaptation as the battery ages that is really unlike anything that we've experienced in the last decades of using batteries.
I absolutely love where this conversation is going. We're going to take a quick break and then we'll be right back at it. Turn everyday shopping into savings with the Upside app. Whether it's fueling up, grocery shopping, or dining out, Upside lets you earn cash back on your purchases without limiting how much you can save. You can even combine it with other coupons, discounts, and loyalty programs, so it's a win-win for both you and the business you're buying from. So buy what you need and feel good about it. For more information and to download the app, click the link in the show notes to support the EV Resource Podcast. Hey, everybody. I just want to thank you real quick for watching, listening to, and supporting the show. Your support is what keeps this podcast going. To get all of the URLs, codes, deals, and discounts from our partners, you can go to ev-resource.com/deals. So please consider supporting those who support us. I would imagine that you have a set, I guess, pairing or grouping of parameters for every single variable at every single point in time. And you had mentioned down to milliseconds. I have no grasp of the actual coding of the software to be able to respond that quickly to, it could be a dozen or so variables at any given millisecond. So first and foremost, I'm incredibly impressed. My mind's blown away. And I like to think of myself somewhat as an engineer. And so it's going to bug me that I don't understand that. Not that I'm going to go get a PhD to learn it, but I'm very, very fascinated and impressed because I do see the value of that, where having the ability to adjust that quickly to the situation as it is in the moment versus something that was programmed maybe 5 years ago before the vehicle was shipped and maybe was updated with an over-the-air update at some point. I mean, I know having connected vehicles allows us to change them after the fact, but you're not going to get an over-the-air update every millisecond. So that is very impressive. Ultimately, from the user's perspective, is all of this just behind the scenes? It's happening without anybody being aware of it, and they are just benefiting from having an experience that is shorter charging time.
Yeah, exactly. So I think let's say, ethos that we bring to the table when we engage the market and our customers, like Volvo, like Oppo today, who have more than 27 different models of handsets with our other product on the market, Breathe Life, that enhances the durability. I think the ethos that we bring in terms of the value proposition or the product offering to them is that we align with the goals that they are trying to pursue and achieve as an organization, the corporate goals, also their product goals. And that's so often making the end user experience more enjoyable, more seamless, more easy, more simple. And we target then a product offering that facilitates that in the most simple possible way. And I think then for that reason, it is the case that we abstract, I'd say, the end user rather intentionally from then the nitty gritty of having to make decisions around how to let's say, look after their battery and simply then provide what is a piece of firmware that is shipping off the production line in these systems to the OEM, so that when their handset leaves the manufacturing line, or the vehicle leaves the manufacturing line, that it's already operating at that moment in an even more optimal way, and that every subsequent moment in time. And I think fundamentally it's just, I think I certainly have a strong opinion that pursuing simplicity in that respect is a good engineering principle, especially for something as complicated as electrochemistry. I think on the millisecond by millisecond point, maybe it's an example of that. I mean, even though batteries then do vary on that kind of time scale of millisecond by millisecond, it's not even necessary in these applications to have control software operating on that frequency and typically our kind of cadence or of sort of running what is a physics-based battery model in the background on these systems is on a second-by-second basis, which ensures a really high degree of compatibility then with the kind of system that you would buy in a Volvo or in a Ford or GM car.
You had mentioned with the handsets more battery longevity because my phone, it charges fast enough. Most of the time, it'll get plugged in and I'm doing something else. Well, kind of the same with the car. I don't need it to necessarily charge any faster, but I want it to last a few more years if possible, because certainly the degradation of phone batteries, because they're not thermally managed the way a car is, they don't last very long. With EVs, we want the battery pack to last as long as we have the car. Well, that's somewhat ambiguous, right? Like nobody keeps the car the same amount of time. And then certainly on the secondhand level, well, somebody might be getting the car 10 years into its life.
Yeah, maybe we try and unpack, I suppose, maybe the longevity side of things and the duration of battery longevity from then it's kind of maybe C rate limitations on the discharge side. And if we think about longevity, I think it is certainly you're dead on in terms of the user typically defines what duration they want to use their application for. Maybe that's 11 years of the average car lifetime or usage time here in the UK. Maybe I want to use it for 18, right? Or maybe you want to stretch it out and so on, right? And ultimately, it's our customer in these kind of markets that then dictates what their design decision is for the product longevity. I think certainly with our Be Life product, many of our customers then have the opportunity to push that out even further with the software for the battery system. I think that what we are seeing is that there's an enormous amount of throttling of the battery system because of uncertainty in this industry to date. And that throttling, that constriction of what the capability of the battery system is capable of, that is occurring in a very layered manner, in a very consecutive manner at almost every stage of the supply chain or the workflow, from when a battery is designed and conceptualized all the way through to when it reaches our hands. And in many applications, it's even happening after the product is launched onto the market. And that might be, let's say, year 1, 2, 3, 4, and 5 of a laptop lifetime. There's additional throttling taking place to restrict the operating envelope or capability or performance of that battery system. And that's happening because these OEMs are backed into a corner today where it's a certainty that they have or visibility that they have into what the battery is capable of or not capable of is limited in many respects, to the extent that they feel the need to protect their brand by throttling the system and decreasing the performance. And of course, that fundamentally takes away then from what, let's say, we as end users have paid for, and it's a negative experience that they would love to avoid, but don't manage to particularly well today. But I think aligning all of that with the lifetime or target lifetime of the vehicle or the device, that's certainly a strategy that, at least in that respect, should minimize throttling. We don't want to throttle it any more than we already are. And I think the message really, I suppose, is that there's an enormous amount of throttling taking place in the supply chain today.
I normally don't call out specific manufacturers, but I'm going to make an exception because Toyota specifically is a glaring example of exactly what you just talked about, where with fast charging, they actually have put into the fine print of what their user manual is for the Toyota and the Lexus. They will only allow a certain number of fast charging sessions within a period of time. You just have to go, all right, they're probably not using some rare battery chemistry or materials that are just not available anywhere else, to the point where they don't know what it can do. And I really, you said it, I think, better than I probably could find the words for, that it's to protect the brand, where they do not in any way want to be the brand that is in the news with any kind of battery failure at all. So they're going to be very conservative. But what that does is it changes the user experience, where you're not going to take one of those vehicles on a longer trip and fast charge 4 or 5 times in a day, because the software will not allow you to do it. They're clearly not using adaptive charging.
Yeah. Yeah, exactly. Look, and I think that that is, I sympathize very much. I think with the OEMs in the respect that I think the state of the art of what's been possible with batteries for the decades prior to recently, and certainly prior to Breathe, has caused that kind of scenario where there's a tricky balance, I would say, or tightrope that they have to walk between delivering the best user experience at the start of the battery life, and then also trying to make it consistent with the least amount of throttling. But I think also, I mean, being very frank about it and transparent, I think the reality of it is that it is a significantly subpar user experience for so many battery systems out there today, where there is a huge amount of throttling taking place. And I think, unfortunately, I'd say that the frustration, I'd say, does gets exacerbated or gets exacerbated in some of the sort of, let's say, quote unquote solution offerings, where so much of the encouragement is to maybe don't charge above 80% instead of charge. But that's just saying really, well, actually, I can't use the damn car or for the distance that I intended to use it for, or the
Right.
laptop for the duration of runtime that I'd like to be productive for, right? And it's further throttling to try and solve another throttling issue. And really, no one's getting anywhere in these kind of respects. And I think then this really is where I think what we are seeing with adaptive charging, let's say, as a product offering, clearly from one organization, and I'm sitting here on behalf of that company, but I'd say more generically, more zoomed out manner, what we are seeing now with the transition in all of these application spaces from battery management that is traditionally black box in the respect that it's what's called an equivalent circuit network representation of the battery, treating it very much like an electrical component, to one battery management system and battery control approach that is physics based and has real time insight into the electrochemical operation, the electrochemical parameters like concentrations, like voltages, like where the lithium ions are and are not at any given moment in time inside these systems. And I think that visibility, and that's something that, I mean, is very close to my heart in terms of what I say study, pursue, and still develop today at the company, but is I think very much underlying then a transition that we are seeing to what is becoming a far more physics-based world in terms of battery management, battery control, and unlocking then scenarios and options for OEMs like Toyota, who you mentioned, and many others of their kind of competitors as well, where they don't have to be in a rock and a hard place, making such unbelievably painful trade-offs and offering more throttling on top of throttling.
Yeah. Yeah. There's a lot of different battery chemistries out on the market, and certainly from manufacturer to manufacturer, even if you have the same components, you might have differing amounts of the various minerals. What you're talking about, it sounds like it would be an easy solution to apply really at scale, being that it sounds like it's almost chemistry agnostic, where it's not going to be designed specifically for this battery chemistry. It's looking at everything, all the different variables, and adapting in the moment to what's going on. Do I have that right?
Yeah, you do. In respect of how our products work at Breathe Battery Technologies, exactly that. I mean, I think being chemistry agnostic as a product offering is part of, I think, the simplicity offering at a very sort of, let's say, value offering level. But on a very practical level, I think it's just incredibly important to be agnostic to, on the anode side, let's say, or the negative electrode side, whether or not it's purely graphite in these cells and these batteries, or whether or not it's a very high degree of silicon doping, which is becoming so prevalent in both consumer electronics and automotive markets today to deliver the kind of the WLTP range, or essentially the vehicle range, the kilometers and miles that we want to drive. And then on the cathode side, I mean, I think we see in the last years, maybe what's been maybe potentially a shocking degree for some of the industry, that the adoption rate of lithium iron phosphate as a fairly dominant cathode chemistry in some respects, because it is such an enabler of low cost systems. And I think not only for us in the, let's say, maybe narrow manner of us at Breathe Battery Technologies, but I think for every entrant, as more and more entrants pour into this battery industry, I think having a degree of versatility and resilience to what chemistry is dominant under what scenario is very important, to try and, I'd say, frankly, make it commercially successful. Because these organizations also, they do a very good job at continuously pulling through the latest chemistry nodes from the cell manufacturers, the Panasonics, the BYDs, the CATLs of the world. And I think that means that we experience then as end users, whether or not we know it, we experience a really impressive rate of chemistry node upgrades that these OEMs are following year on year.
So without this, you have to package the battery, every part of it, very carefully, not physically package it, but in terms of overall design, every part of it is extremely important. How you design cooling systems, what materials are used for the casing itself to handle heat, whether you're using a pouch cell or cylindrical, all of those variables impact longevity, performance, charging speeds. With adaptive charging software, are all of those things not quite as important anymore? Where could it allow for somewhat of, I don't want to say sloppy, but less of a meticulous approach to all of the other parts of designing a battery pack?
That is for sure a really interesting question. I think it unlocks like a super cool route of discussion for us. It's not the case, certainly in my opinion, that it allows any degree of sloppiness. And I think that so not directly in that respect, no. I think clearly I think that there's such an unbelievable drive from both the safety and the cost perspective to keep the manufacturing yield and so high and the tolerance is so low and tight that I think there's no, let's say, room for maneuver in terms of what materials we put in or what way we configure the design or the manufacturability or geometric factors of these cells. But I think what it does unlock, I'd say, is this route, not just through adaptive charging and products like Breathe Charge, but this transition more fundamentally towards more physics-based battery management software solutions that can extract the capability that's locked up in the materials and electrochemistry. What it does allow for is this kind of two route option going forwards, where customers of ours like Volvo today and like Oppo, they're able to add performance along some metric. And in the case of Volvo, that's charging speed and charging consistency. In the case of Oppo, that's cycle life and durability. And they're able to access that performance enhancement without a subsequent trade-off, right? And that's super beautiful for them. And that's for them then just this like really super complementary pathway to everything they're doing on the hardware and the chemistry side. But the other route that's available then, like very much to your really solid point, the other route that's available to all of these manufacturers going forwards is that cost is so critical, and I think we see that so much more than anywhere right now in electric cars as we try to, I think, collectively as a population displace more and more internal combustion engine cars. And I think what is certainly possible is that instead of only following the route of adding performance onto these systems and maintaining a similar cost or passing on that cost to the consumer, what we can also do is rather substantially reduce costs and make up for, let's say, maybe a different material choice, a different design choice, a different manufacturing choice with the performance that's then available through enhanced software. Let's say software-defined batteries, adaptive charging, physics-based battery management systems. And that really is a really beautiful pathway to unlocking lower cost batteries. And I think, again, in the same way that the performance is complementary to all of the hardware and chemistry advancements that are happening, that cost reduction is complementary to what's happening with the same economies of scale, the better materials, and so on. And I think this is really empowering for, I think, what we see with these battery systems.
I think you just explained what I meant with that question better than I asked the actual question itself. So
good that it's working. The discussion's working.
Exactly that. Where having the a little bit more freedom and flexibility to make decisions that, especially with low cost. I mean, that's talked about so much about getting battery costs lower to make EVs more accessible to more people. So that is extremely important. Naturally, everything we've talked about so far is applying it primarily to the OEMs, where I find that to be fascinating because traditionally in the automotive world, a lot of the research and development is done on the motorsport side of things, and we pull from that and it kind of trickles down and finds its way into the passenger vehicles. In your experience, have you seen this technology being used in motorsport for one purpose or another? And then, well, I'll save the other question for after that. So,
Yeah. I would personally love to see more adaptive charging, and essentially also more broadly also more battery technology development in the context of motorsport. For sure, that would scratch my itch of finding this crossover of applications between batteries and race cars. I think it's really interesting question, and I think the reality is a little bit more depressing today than I think it could be, or than the excitement that the question evokes for me, certainly. And that's that. I think Formula E, for example, as a series, has been around for what is it already a long time now. I think it's coming up on
oh
10
yeah.
years, if not
Mhm.
10 years already. And I think what we have is now a transition to a new battery system supplier there, with Podium Advanced Technologies out of Italy supplying what's going to become the next generation of vehicles for that. And I think for completely valid cost reasons, that series historically and in the next stage of its evolution as well is limited, I would say, probably from an R&D perspective, to there being a single battery system supplier. I think if that wasn't the case, the rationale I think is reasonably solid. It's that there would be an almost unlimited cost war on battery development, to the extent that you wouldn't have teams able to financially operate, you wouldn't have a series and so on. I think maybe my personal opinion is that in Formula E, it's a little bit too extreme. I think there should be more battery development allowed than a single system supplier. But I would say that maybe in a less structured way, a similar sort of problem exists throughout the motorsport sector. Is that there's not a great structure within which yet. It's not a series that unlocks battery development to the right amount that allows for the investment of the sufficient amount of R&D and real R&D to happen there. I think that's probably what I feel personally is rather depressing in that respect. I'm really hopeful that changes and we do see more happen in a motorsport context. I think it's good for everybody. And so much of the safety advances, of course, that we experience today as passengers in cars come from that scene. I think in reality, the R&D is happening today in the cell manufacturers, in the OEMs like the car manufacturers, and the R&D is happening then in some incredibly ambitious startups and younger organizations like Breathe and some of our compatriots and colleagues around the world. And I think the reason it's happening in a passenger electric car sense, let's say, or it's driving it, such an incentive there, is that these brands, the Volkswagens of the world, the Fords, the General Motors of the world, and the Geelys, the BYDs, and so on, their very existence and their very brand is now transitioning away from something that was almost entirely defined by the engine or the note of the exhaust pipe, right, and the sound waves there, through to it being electrified. And then if it's electrified, really the battery is the core component, partly because it's cost and partly because it defines so many user attributes. And then if you look at the battery, I mean, what is it defined by? It's defined by essentially two things. It's defined by the chemistry, defined by then three, really, maybe then the ability to integrate the systems and subsystems of it. And then thirdly as well, the software, right? And I think fundamentally the overall vehicle becomes massively software defined. The battery becomes incredibly software defined. And then because the brand and the, say, future state and the survival, frankly, of your organization depends upon it, there's an incredibly strong forcing function in these private companies that sit outside the motorsport realm largely to drive innovation on the battery from a hardware and software stack perspective.
I'm going to ask you to make a prediction.
Risky.
Almost every vehicle I have owned, and that is quite an extensive list, I have tinkered, modified, tried to improve one aspect or another. Recently, for the last 7 years or so, I've been on an efficiency kick. So every vehicle, I want to make it more efficient, use less energy per mile, whether that be gas or electric. When do you think, this is the predictive part, when do you think we will start to see everything that we've been talking about be accessible and available either in kit form or be able to be applied by the DIY person, the backyard mechanic, somebody that certainly in the future it's not going to be what we've been used to, but they're going to need to have a laptop that communicates with the car, that can load software onto the computer. When do you think we'll see it, if we do ever, the ability to get down to this level of, in a way, fine tuning what's available for that group?
That is indeed a tricky question. If we think through maybe what might make it happen, I suppose is maybe a helpful way, especially for me to think it through. I think that the constraint, I think, is probably safety more than anything on how fast it can happen. And maybe in one respect, maybe regulatory is another constraint. Yeah, as well. But I'd say primarily there's a solid safety argument that drives an awful lot of caution around that. And I'd say that where it's very different, of course, for the internal combustion engine, despite it containing quite a reasonable amount of flammable material with a petrol or diesel tank or so on, right? I'd say there's a good, there's a good degree of familiarity built up in the last, century, right, of how
True.
to tune your carburetor or mess with your fuel injection map and so on, right? But I think that familiarity hasn't been built up with, so that kind of caution gets exemplified or amplified in the battery space. I think if we think about the other side of things, what's the forcing function for it? I mean, again, maybe actually touch on the regulatory point. What we might see that accelerates that somewhat is the regulatory drivers around us for more repairability of systems, right? And I think that we see from everything from tractors today through to smartphones and maybe organizations like iFixit that support these and many other groups. We see, I think, quite a bit of tailwind behind then there being right to repair laws, right, that support you and I breaking out the tool chest or the laptop, as you say, right, and be able to play with the system. I think those repairability laws and regulatory drivers are super, super important. Probably that plus a combination of some kind of like hobbyist desire that certain brands want to associate with and lean into to do good for themselves. I'd say would probably be the driver that makes it happen. I really think that we do need to see more penetration of cars before the critical mass gets to the point that we can break out the laptop and play. And I think that something is going to happen very fast. I think that we'll see adaptive charging, we'll see physics-based battery control get adopted incredibly aggressively in the next years, the next 3-5 years. I think that we're probably, as depressing as this is personally, I think we're probably looking at 2020, let's say 2028 at the earliest, 2032 with maybe the latest, to see some kind of onset of really being able to have a kind of hobbyist community, a maker community, or kind of repairability community around these systems.
Fine, I'll wait.
Yeah. If we all do the job of buying more cars in the meantime, I think that we put more money into the system, and there's more rationale there. Right? There's more cars that are there to play with. I mean, that's provokes it, supports it.
Yeah, I remember the first time I was working in a car dealership. I had a Toyota that I was modifying quite extensively, and I remember one of the other technicians said, "If you want a better car, why don't you just go out and buy one?" And well, at the time, I wouldn't have been able to afford to, but the true answer is, I want to build what I want because it gives me the opportunity to not accept the compromises that are applied to a consumer vehicle in order for it to be appealing for thousands and millions of people. I want something for me. So maybe in my own selfish way, I want the software side to evolve as well.
Do you own a business and want to reach EV owners and people interested in electric vehicles? EV Resource is welcoming businesses nationwide, both big and small, to become advertising partners with us across all platforms. The EV Resource podcast, YouTube videos, social media, and our webpage. For more information, please email Zack at hello@ev-resource.com.
We have covered a lot, and so I want to thank you for that. Before we end this episode, though, I like to ask my guests two questions. And the first is fairly straightforward, and that is, out of curiosity, what vehicle do you drive?
I actually don't have a car at the moment, so I commute mostly by bicycle is how I get around. It's really trying to facilitate the lowest carbon form of transport, but also I live in central London as well. So
Sure.
if I can get away with it, there's a pretty good incentive for not having a car in the city. Uh,
You are
I think that my our customers here at Volvo will be very pleased, and I think it's highly likely that when I do purchase one, that my car is a Volvo. But we'll see what other customers we can bring online in the meantime that give me optionality in respect to that.
certainly, certainly. And the second of the two questions is a play on the word drive, where instead of what do you drive, what drives you? And I think we've probably covered that a ton, even from the very beginning of when you were introducing yourself and your background. But I'll give you a chance to answer the question anyway, and possibly put it in a slightly different perspective.
Yeah. I think in a professional context, I think that we have an enormous opportunity as an industry, but then maybe more granularly as a company to change what's possible with batteries. I think I became frustrated by that originally, probably like the sort of at the onset of the PhD program in 2015. And I think got more clarity as to how much room for improvement there was through that PhD until 2018, 2019. And I think in the 5 or so years since founding Breathe and spinning it out of Imperial, I think that frustration's only grown as we understand more and more of them, the, let's say, legacy methods of building charging strategies, and even more broadly, just the legacy method, the degree to which the industry in the world relies on legacy methods of controlling batteries with some very, very outdated methodologies. So I think what drives me in a professional context from a, let's say, performance and cost perspective is unlocking that and seeing that. And I think doing that thing that I couldn't really visualize when I was a kid, and I was looking at that kind of fuzzy logic charger, and being able to consider what is the best possible way of looking after these systems and developing them, and then being able to deploy it so that you and I have a better experience. I think that's certainly a major driver for me. And I think maybe more close to home, more close to where I'm sitting today. I think we have a team now of over 50 and very, very talented individuals from about 14 different countries around the world. I think we've managed to collect now 14, 15 PhDs as well as part of the company. And I think giving them the option, regardless of when they enter this kind of sphere or space, giving them the option to enjoy and push on what we started with Breathe and this industry needs, I think is really fulfilling. And I think also I would very much like to see the cars, I think, not spewing out the toxic gases in the environment around us for the health of our lungs and our kids and our families as well. And that would sort of a zoomed out view and maybe a slightly longer term as we collaborate with the rest of this industry to facilitate more adoption of electric cars. I think that would make me very happy.
Was that the catalyst behind the name Breathe?
That was exactly the catalyst. And I think one of my co-founders was standing as well next to the bus stop with his young daughter. She's a bit older now, but it was about 3 years of age, or yeah, a bit less even at the time. And the buses here in London are pulling away, and particularly if you see some of the older buses, then they emit a very noticeable black mass of cloud behind them, and that is a rather scary sight to see. And you see
right there at
like
head level, where for children.
Yeah, the children are. Yeah. So I think the fact that we wake up every day and we go to work to make the battery better, as well as that, let's say that longer term vision that we have for air pollution no longer being so prominent. I think that's helped us to eventually converge on the name.
Well, with that context, it is extremely appropriate of a name.
Yeah.
So, Dr. Ian Campbell, I want to thank you so much for joining me. This has been extremely enlightening, and in many ways, I will probably walk away from this conversation frustrated in that it's illuminated something that I have a lot to learn about, and that the way I work, I tend to get obsessed about learning new things. So you might have set me on a path that who knows where it'll lead. But either way, I want to thank you very, very much for spending your time to share both with me as well as the audience about this technology, because there's no doubt that it is one more revolutionary step to get to where we need to be.
Yeah, exactly. I hope that we set many more people on the path, and it's been a pleasure, really enjoyable. Thank you very much.
I really hope you've enjoyed this podcast and want to thank you so much for being here. If you haven't left a review or rating on Apple Podcasts or Spotify, I'd really appreciate it. And if you have any feedback for the show, questions for me, or just want to reach out and say hi, you can email me at hello@ev-resource.com. The EV Resource Podcast is a production of EvoSpark Media Group and is supported by viewers and listeners just like you. Supporters of EV Resource on Patreon include at the director tier, Rajeev, Narayan, and Andy Cooper, and at the executive producer tier, Christopher Lawrence and Dave Laansma. To get ad-free episodes of the podcast, free EV Resource merchandise, support recognition, and to join in the community discussion, you can head over to patreon.com/EVResource. I've been your host, Zack Hurst. Thank you so much for watching and listening, and I'll catch you next time.